Good morning, guys. Today we're going to look at adding and subtracting rational expressions. In the last section we talked about multiplying, dividing, simplifying, and we identified how the rules for rational expressions are identical to the rules for rational numbers, for fractions. So it's going to be the same thing when we add or subtract. We know that if we add or subtract something, we're just counting up how many of that something we have. So if it's fractions, we're counting up how many of that specific denominator that we have. So for us to be able to add or subtract fractions, we've got to get a common denominator. It's no different with rational expressions. For us to be able to add or subtract them, we've got to get a common denominator. First thing we need to do is factor each denominator. That lets us know exactly what do they already have in common, what do I need to bring into one or the other to finish them off, being common denominators. So if we look at our example right here, 5x over x squared minus 9, minus 3 over 2x minus 6. Factor those denominators out. I've got a difference of two squares here. 5x over x squared minus, 5x over x plus 3x minus 3 minus 3 over common factor of 2 times x minus 3. Notice we don't touch the numerators, even if these are monomials, but even if I had multiple terms in those numerators, I wouldn't mess with the numerators because I don't care about the numerators right now when we're factoring or when we're adding or subtracting, because they're just going to get all messed up anyways when we start combining those numerators together. So what we want to focus on is factor those denominators, and so we can see what's in common. Well, we can already see that they both have an x minus 3 in common. Well, I don't need to touch the x minus 3. Step 2 says multiply numerators and denominators by necessary factors to get a common denominator. Fancy way of saying multiply by what's different. So if they already both have an x minus 3, I don't multiply by that. I multiply by what's different. The right side has a 2, so the left side needs a 2. If I do it to the denominator, I've got to do it to the numerator to keep that fraction balanced. What's different about the left side now? It has an x plus 3. So I've got to put an x plus 3 in both the numerator and denominator. Now we can see we have identical denominators. Identical factors of the denominators. Remember, the order doesn't matter for factors, for multiplication, because it's commutative. 2 times 3, 3 times 2, it's all equal to 6. So as long as we have the same factors, they look the same and they have the same amount. Okay, so if I had an x plus 3 squared, I'd have to have 2 x plus 3's on the other. But in this one, we've got 2 and 2, x plus 3, x plus 3, x minus 3, x minus 3. So we've taken care of the multiply by what's different. Now it's combine those numerators together. Remember, adding and subtracting, you're combining the coefficients. You're combining those numerators. What is it we're counting up? We're counting up how many of this denominator do we have. So we have whatever that combination of numerators is. I like to leave it. I don't want to distribute those out yet because a lot of people will lose this minus sign when they start distributing before they combine. So I'll combine my numerators together first. Get the right marker. And I'll do 2 times 5x minus 3 times x plus 3 all over my common denominator. 2 x plus 3 x minus 3. Now, again, I write it like this so I'll remember to distribute negative 3 to the x and the positive 3 over here. So I'm going to distribute this whole thing. Another common mistake people will make is they'll be, I've got an x plus 3 here, I can cancel it. I've got a 2 here, I can cancel it. Because they're thinking like we did when we were multiplying. Difference is that's not a multiplication symbol. If that was my problem, yeah, x plus 3 and x plus 2 are factors of the numerator, factors of the denominator, and they can cancel. Here, x plus 3 and 2 are factors of the denominator, but it's not a factor of the numerator. 2 is a factor of this term. Remember, terms are things we add and subtract. 2 is a factor of this term of the numerator. X plus 3 is a factor of this term of the numerator. So if it's not a factor of the entire numerator, then it's not a factor that can cancel with a factor of the entire denominator. So when we're at this point, when we're on our combine step, we're going to just put it all together as one fraction. Then we're going to distribute and combine like terms. So as we go through there, I've got 10x. I'm going to distribute that negative 3. So I've got negative 3x minus 9. Don't mess with the denominator. Just like we talked about before, it depends on the preference of whoever your teacher or professor is, and as to whether or not they want you to finish this numerator or denominator out. But for what we're doing right now, just leave it in that factored form, because that will give us a lot more information than distributed and combined like terms. The only reason we're distributing in the numerator is because we don't have a single expression yet, and we have two terms over there that need to be combined. So 10x minus 3x gives us 7x minus 9 over 2x plus 3, x minus 3. And we remember our last step is to state restrictions. Anytime we're working with rational expressions, have to state restrictions because we know the denominator cannot equal 0. We don't want any black holes opening up because we've created this singularity here in the middle of the classroom. So we state what x cannot equal. So x is not equal to anything that ever showed up in a denominator. These are usually pretty easy because we don't have things canceling out that much. X plus 3 cannot equal 0, so subtract the 3 over is negative 3. X minus 3 cannot equal 0, add your 3 over. Just remember, we're taking each factor, saying it cannot equal 0. Well, obviously 2 does not equal to 0, so we don't have to worry about that one. Here I'm going to subtract the 3 over, so x is not equal to negative 3. Here I'm going to add my 3 over, x is not equal to positive 3. So x cannot equal plus or minus 3. So that is our final difference of these two fractions, 7x minus 9 over the quantity 2 times x plus 3 times x minus 3, where x is not equal to positive or negative 3. And that's adding and subtraction. It doesn't matter if that's a plus sign or a minus sign, because that's going to get brought in right here. So don't multiply. Don't get in too big of a hurry. Combine, then multiply, or then distribute those numerators out to their new factors. And remember, constants don't become restrictions because they don't have an x anywhere in them. Okay, guys, last thing I want to talk about is complex rational expressions or complex fractions. Complex rational expression has fractions in fractions. It looks a lot like this big old nasty beast. Now we see a lot of fractions. We see some addition there. So when we're working with complex rational fractions or fractions within fractions, let's just rewrite it as a division problem. So what are we dividing? We're dividing this whole numerator by this denominator. So I'm really taking 2 over x squared minus 1 plus 1 over x plus 1 and dividing it by 1 over 3x squared minus 3. Now, if I'm going to work this problem out, we already wrote it as a division problem. Now let's just take it piece by piece. We know order of operation says take care of the parentheses first. So we simplify inside these parentheses until I get one expression divided by another expression. Then it just becomes a division problem. Multiply by reciprocal, state restrictions, and so on. So that's what we're going to do with this beast. We're going to take that left side. We're going to add these together. So we remember that if I'm adding fractions, I need to get common denominators. So I'm going to start, let's rewrite it up here, 2 over x squared minus 1 plus 1 over x plus 1, all divided by 1 over 3x squared minus 3. Okay. So I need to factor my denominators. So that's 2 over x plus 1, x minus 1. This denominator is already factored, 1 over x plus 1. I'm just going to put this on hold. I don't need to address it at the moment. So identify what's in common, multiply by what's different. So both factors, or both denominators, it's already factored, have a factor of x plus 1, so it means the right hand needs an x minus 1. Combine your numerators, 2 plus 1 times x minus 1 over x plus 1 times x minus 1. Keep your common denominator, combine your numerators. I simplify that down. Well, this is just 1x minus 1. So we're going to get, what's that end up being? 2 minus 1 is 1. So that's going to give me x minus 1 over x plus 1 times x minus 1. So that actually gets really nice because I can simplify this a little bit, can't I? Okay. So I have x minus 1 as a factor of the denominator, and that entire numerator is x minus 1. So x minus 1 is a factor of the numerator. That means I can cancel both of those out. And my division problem ends up becoming, because this just kind of divide by this, still divide by this, divide by this, divide by this. It's just been trailing along the whole time. So my big division problem becomes 1 over x plus 1 divided by 1 over 3x squared minus 3. Now we know now that I have fraction divided by fraction, I can go in and just change it to multiply by reciprocal when we follow our multiplication rules. So 1 over x plus 1 stays where it's at because we're dividing by the second one, so we're reciprocating the second one. Times 3x squared minus 3 over 1. Factor, so 1 over x minus 1 times, has a common factor of 3, is going to give me x squared minus 1 over x over 1. Still factoring it down, 1 over x minus 1 times 3 over a difference of two squares, x plus 1, x minus 1 over 1. Now we put it together, remember multiply, put those numerators together, denominators together, and this factor right here matches this factor up here. So the x minus 1's cancel, and what do we end up with in the end? We end up with 3 times x plus 1. And as with everything, we have to state restrictions. Restrictions were anything that make a denominator equal 0. Any denominator, anywhere. So I have to look at my problem, and anywhere that a number was in the denominator, it would make it equal 0. So for example, 1 or negative 1 right here, okay? So back right here, plus 1 and minus 1. So this denominator, if x was plus or minus 1, it would have given us a 0. So x is not equal to plus or minus 1. Here, x cannot be equal to negative 1. Here, x cannot be equal to negative 1. So all of those denominators checked out to be either plus 1 or minus 1. If for some reason I'd had an x right here, or some polynomial expression right here that was not a constant like what we have, then I would need to check that also, because technically this is a denominator of this. So any denominator anywhere in the problem has to be checked and has to be put down as a restriction. So our final expression, this big old nasty thing, comes down to 3 times x plus 1, where x is not equal to positive or negative 1. That's adding and subtracting rational expressions and simplifying complex fractions. I will see you in class tomorrow, guys.